Hello everyone, my name is Franco Pucci. I'm the technical consultant for the STS Association and I've been involved in the prepayment industry for over 25 years. Welcome to the STS training video series where we will explore all aspects of STS and the STS standard. I hope you find these videos helpful. In today's video we'll be looking at the key agreement scheme. A key agreement scheme is used for transferring keys securely between the key management center and the security module. It's quite a complex process, so let's have a look. The key agreement scheme is contained in the document STS 600-4-2. There's a few definitions or acronyms at the bottom of the screen, which you can see. VK is a vending key. KEK is a key exchange key. HSM is a hardware security module, sometimes also referred to as SM, security module. DKGA, decoder key generation algorithm, and SMK, system master key. So let's have a look at where we are. Well, let's start with the key management center. The key management center essentially generates vending keys, public keys, etc. These are all protected under a system master key and stored away in a database. The KMC has also a high security hardware security module associated with it, which generates these vending keys. The VKs are stored in the database encrypted under an AES 192 system master key. It also stores all supply group codes, HSM public keys, and all metadata associated with supply group codes and customers. Then you have the secure module manufacturer. The secure module, once a secure module manufacturer wants to manufacture secure modules, essentially the HSM generates an EDSA public key, which it sends to the key management center to verify the HSM public keys. And it sends these using an ECDSA P384 algorithm. Then the secure module from the manufacturer, each one that he makes sends an HSM public key to the key management center to establish a key agreement. And this is done under ECDH P384. Once this key agreement is established, it means that then there's a shared secret between the KMC and the security module, and it means they can transfer VK load request can come from the HSM to the KMC, and a VK load response can come back containing keys, and we'll see that in a minute. Each time a new secure module is introduced into the market, and by that I mean a new firmware version, then this STS association sends a configuration file, a signed configuration file, to the key management center, which essentially contain a list of approved supply group codes and approved security modules. This is then married up at the KMC with a request from a security module. It checks that this is in fact an approved security module, and then it will allow the VK load requested. The HSM manufacturer then distributes the security modules into the field. Then when the field security module requires VK load or keys, first of all it gets the public key from the key management center, which is published to all secure modules. In fact, all manufacturers, you can get this off from the key management center at any time you like, and that is used to transfer the VK load request to the KMC. So the HSM then requires vending keys. It sends a VK load request to the key management center using the KMC public key, and it sends this as a plain text file by email. The key management center then ensures that it's a correct VK load request. It then takes all the keys that are allocated to that particular security module and sends back a VK load response using the key agreement public key of that security module, which was established a lot earlier in the key agreement scheme. and the keyload file is sent back by email. Then at this point, after all the keys have been loaded into the security module, then essentially the secure module can be connected to a vending system, either as a standalone unit or as a high-speed unit, as we saw before in one of the previous videos. And then it can also be a manufacturing system, by the way, where you have a manufacturing module that requires supply group codes in order to code meters. The system will generate decoder keys using the vending key that it's got out of the vending keyload response, and using either DKG-AO2 or DKG-AO4. And then tokens can be generated, and these are encrypted under the decoder key with EAO7, which is a 64-bit algorithm, or EA11, which is a 128-bit algorithm. That's quite a mouthful, but it's essentially how the system works. It's critically important that the transfer of information is as secure as possible. If you're interested in a more detailed explanation of this key agreement scheme, then by all means download a copy of the STS 600-9-1 document, which gives a detailed example of this key agreement. Most people will never even use this. It's really more for secure module manufacturers or designers. However, it's there if you want to have a look at it. Now let's have a look at the keyload files and how they work. Okay, if you remember the yellow bits here, the secure module sends a vkload request to the key management center by email, and then it gets a vkload response back to that security module also by email. Now what do we do? So the vkload request has a beginning and an end. So a vkload request begins and a vkload request ends. Then you have a record type, and in this case it's a vkload request record. Then you have the secure module ID, in other words that's the secure module that is sending the vkload request. You have a key management center ID, so the secure module must only send vkload request to the KMC that it is allocated to. In this case, for example, it's the STS-A test KMC. You have a time variant parameter from the secure module, and that is used to timestamp the vkload request that comes through. You have then the hardware ID of the security module. Once again, as an example, I've used a Prism TSM 250-1. You have a firmware ID, which in this case is STS65V02. Now that firmware must have been approved at the key management center using the configuration file I mentioned before, otherwise it will not be accepted. And then you have an ephemeral public key, and that changes, this changes continuously, and it's part of the key agreement scheme. And then you have a message authentication code, which essentially ensures that all of the data preceding this has not been tampered with during transport of the data. And then you have a CRC of the entire message, which is a much lower security method of checking that nothing's been tampered with. Then you get a vkload response coming back from the key management center. You have a record type, which is a vkload response. You have, once again, the KMC ID that it came from. You have the secure module ID that it is destined for. You have a time variant parameter, once again, marking when the vkload response was generated. You have a message authentication code to ensure that the message has not been tampered with. And then you have 1 to n key 1 type records. Each one of these key 1 type records is in fact a vending key with this associated metadata. If we look at the key 1 record itself, you have a number once or nonce, which is not repeated. You have activation date of the key, ACT, that tells you when the key is actually active and ready. And you have base date, currency credit limits, cluster, DKGA, all sorts of parameters that come back for that particular key inside that key record. And then right at the end of it in blue, you have the actual vending key itself. Now obviously that is not the vending key, that is the vending key encrypted. Okay, so you can't use that as a vending key. Let's look at the key attributes that come through. That's all the red bits in the bottom section. Activation time, or ACT, is the date on which the key becomes active. Prior to that date, it is unusable. The base date, this is the base date associated with the key. That's either 1993, 2014, or 2035. You have a currency credit limit, which is the maximum amount of currency the secure module may vend. The cluster, a cluster of supply group codes that this key belongs to. Normally this is set to 0. The DKGA, will it use DKGA02 or will it use DKGA04? Obviously DKGA02 will be obsolete pretty soon due to the TID rollover, and only DKGA04 will be used. The key expiry date, the date on which the key is no longer usable. That is the final expiry date of that key. Issued until the date before which the key must be refreshed. Okay, so you need to refresh it either every 30 days, 60 days, up to 365 days. And we'll talk more about that later. Key expiry number, a date after which the secure module no longer vends credit. It can still do key change tokens, but not credit tokens. Then you have the key revision number of the vending key, the key type, whether it's unique, common, or default, the subclass bitmap, which tells us which subclasses the secure module is allowed to vend credit for, the supply group number and name, the key check value, which is really a sort of signature to check the value of the key is correct, and a unit credit limit, which is a maximum number of units that the secure module may vend. Things to note: when doing key loading, all keys are loaded into the secure module from the keyload file. No partial key loading is allowed except for manufacturing modules. In other words, when you load the keys, every key in the keyload file will be loaded. You can't do half of them and stop the process. All keys are deleted when loading a new keyload file. And this is done so that if you have a key revocation happening and one of the keys that you were allowed to use before you're now no longer allowed to use, then that is the reason the keys are all first deleted and then the new VKLoad request keys are loaded in. All keys that the HSM has the right to use will be contained in the file. Okay, so if I remove your right to use one of my keys, the next time you ask for a VKLoad, send a VKLoad request, that key will be removed from the VKLoad response. The key register numbers are not contained in the key1 record as per the legacy keyload file. These register numbers are allocated by the security module at the key loading time. Keys that have expired will not be contained in the keyload file. A keyload file cannot be re-entered into a security module since it will only be seen as old. In other words, once you've entered it and it's accepted it, if you try and enter it again, it will be seen as an old keyload file and it won't take it again. And this is to stop people entering a keyload file that has a revocated key in it. Then you get the key revocated and you want that key back. If you could enter an old keyload file, then it would be pointless having a new keyload file with a key that's been removed. The system wouldn't work. Keyload files can only be used for the secure module that they are meant for. So you cannot use a VKLoad response from one secure module and try and load it into another. It won't work. If we look at a comparison of a legacy keyload file, we can see there that all you have is a record type 9520 from line 2 on. You have a key register. Now that key register is where that key will go. We don't have this with the new file. It goes wherever it finds space, and then you need to find out where it's been placed. You have the attributes of the key in white, and then you have the supply group code in green. Now these files can be replayed. There was no key revocation, so you can for example load a keyload file and then go back and load a different keyload file, and it will put the keys in accordingly to whatever is contained in each of the keyload files. This brings us to the end of this part of the video series. I hope you found this video helpful, and I hope you'll join us for the rest of the series. Goodbye and see you again soon.